Hello and welcome to my guide on custom water cooling, all about how you, yes you, can build your very own custom water cooling system. This guide is made by an amateur who has recently built their first custom water cooling system for a school project. This may sound like a disadvantage, but I still remember what I wanted to know before building my custom water cooler, and I hope to pass that knowledge down to you. I am trying to make this video fast-paced. However, to make the video faster for your viewing experience, here are the timestamps for the parts of the video in case you only need one part of the video. This video will mainly be focused on CPU custom water cooling using soft tubing. This is because I have no experience with any other type of cooling, such as GPU or motherboard water cooling. Now, what will you actually need? You will need a water block, tubing, a pump, a reservoir, fittings, a radiator, fans, coolant, and optional extras such as a flow meter. Now you know what you need. What do the things actually do? Well, to start off, the water block acts as a heat exchanger between your heat source, whether it be a CPU or GPU, to the water inside of your custom water cooling loop. The pump then pumps the water through the tubings to your next system component, which could be the radiator. The radiator then exchanges the heat inside of the custom water cooling system into the air, thereby expelling the heat. This is done through the use of fans which are mounted directly onto the radiator, which blows air through the radiator. The reservoir is what you would expect, a container for all your coolant. This helps you fill the system and drain it. Oftentimes you can find radiator and pump combos. These are generally cheaper and are just as effective as two separate units. Now comes the coolant. The coolant simply holds all the heat and transports it from heat source to radiator. The coolant is normally distilled water. However, it is recommended that you put biocides and anti-corrosives into the mix. You can also get pre-mixed one like I did, and optionally you can add dye in order to bling up your system. Lastly, we have the fittings. The fittings simply connect component to the tubing. Some things you want to keep in mind is that the pump and reservoir, especially the pump, should always be as low as possible. This means that gravity will make sure that these two are always filled with water. If a pump runs dry, it can potentially damage the pump. One thing you always want is a positive airflow. This means that there is more air coming in than going out. The opposite is true for a negative airflow. A neutral airflow is always what you should aim for, is when the air coming in is the same as the air going out. My computer is a bad example of this, as it is a negative airflow. I did this in order to keep the testing fair, as I wanted the fans to be kept in the same locations throughout the testing. Now you know all about the parts. How do you choose which ones you want? There are a few things you want to consider when choosing each of your parts. Firstly, I would choose a company's ecosystem of parts. This helps ensure compatibility, and if you have an issue, getting online support is easier because you only have to go to one place. I decided to go with EK because they have a nice reputation and are well stocked in the store I used. Let's start with the water blocks. I would first decide what metal you want to use for your water block. This way, if you have multiple water blocks, there's a less likely chance the metals will corrode. The two most common metals are copper and nickel. If you mix metals, you will need to put anti-corrosives into your coolant in order to prevent damage. In the case of finding what water block works with your CPU, first find out what socket your CPU uses. In my case, it was 1151. Now, find a water block that supports that socket and you should be set. To choose your radiator, find out what radiator sizes are compatible with your case by looking at your case's webpage. These are the options you have for your radiator. There are a few things you want to consider when picking a radiator. First is thickness. The thicker it is, the better it is at cooling. However, this may cause clearance issues. The next thing is fin density. The higher the fin density, the better the cooling, but more resistance the fans have to put up with. As a general rule of thumb, the bigger the radiator, the better the performance. Now pick your fans. Decide how many you need. If you want to fill out one side, you only need to get as many fans as it needs to fill out one side. However, you can do a push-pull system which has fans on both sides of the radiator. You will need to double the amount of fans you need for this. For radiators, make sure you buy static pressure fans. These work better with radiators and are the ones with thicker fins, compared to the airflow-oriented fans which have thinner fins. To pick a pump, I would personally just look at the reviews. The one with the best reviews is the ones that I would buy. This is unless you want to make a massive custom water cooler, which you may need a more powerful pump. I would personally look into buying a radiator and pump combo. They are cheaper and just as effective. I used one in my build. The only major difference between reservoirs are the size and how many ports they have, and just like the pumps, the mounting solution. Now it's time to choose the fittings. First, choose which type you want, depending on how much money you have. Compression or barb. The only difference is one comes with a tightening solution built in, the compression fittings, and one you will need your own tightening solution such as a zip tie or a hose clamp. I would spend a little bit more on the fittings due to most leaks happening here. For tubing, tank, it does not matter too much about the size of the tubing. The only real difference it makes is that thicker tubing is harder to kink, meaning less resistance in your system. When buying tubing, make sure that the size is the same as the fittings or else the tubing won't fit properly. For the coolant, you can either use distilled water and antibacterials, and if you have a mixed metal system, anti-corrosives, or you can get a pre-mixed one like I did. This has everything already mixed in so you don't have to worry about anything. If you want, you can also bling up your system by putting in some dye. Lastly, look at the reviews of the parts you have chosen. This will help you determine, through first-handed sources, if your part that you chose is good or bad. Now finally, we've got all that annoying prep work out the way. It's time to build. The first thing I would do is to install the core of the system. Your water blocks, your radiator and fans, and the pump and reservoir. First off, if you need to uninstall your old cooler, go and do so. Use a tissue paper and wipe a bit of the thermal paste off after you have taken it off. Then polish it using a tissue paper soaked in a little bit of isopropyl alcohol. The higher the percentage, the better. A quick disclaimer, most companies have different mounting solutions for all their products, so your things might not be the exact same as mine, but it'll probably follow a similar step. Let's start off with the CPU. When installing a higher end CPU block, almost always it will come with a backplate. You mount the backplate on the back side of the motherboard, and often you then screw in the backplate through the front of the motherboard. Now apply the right amount of thermal paste onto your CPU die. For my Kaby Lake i7-7700K, this is about the size of a small pea. Now mount the CPU water block onto your CPU using the instructions provided in the manual. Use an X-like formation, screwing in the screws diagonally. In my case this was top left, bottom right, then bottom left and top right. But wait, don't screw it in all the way yet. You want to use the formation you established and repeat it 2 to 3 times in order to get an even spread of thermal paste. Next, mount your pump. In my case, this is a pump and reservoir combination. This part may vary the most because there are lots of different pump mounts. In my case, my pump mount didn't mount properly, so I had to drill 2 extra holes. From there on out, just follow your instructions and use the right screws. I luckily had a mounting plate for my pump. This made it easy for me because I got to work outside of the case. I then mounted my radiator. Luckily, similar to my pump, my case had a radiator mount. This made the process very simple. First, I screwed on the fans onto the radiator using the longer screws in the push configuration. This means the air is being pushed into the radiator. You can tell which way the air will flow because on the fan, the air will always come out of the side with the frame. Now I use a shorter screws to mount the radiator onto the mount. In your case, it may be directly onto the case. When you are putting your radiator and fans into the system, remember to plug in your fans into the CPU headings on the motherboard. Now it's time to add the fittings. I had compression fittings, which come in 2 parts, the barb and the cap, as I like to call them. You can buy cheaper fittings that don't come with the cap and use zip ties or hose clamps instead. To use compression fittings, you want to put the cap onto the tubing and then put the tubing onto the barb. Afterwards, you want to screw in the cap onto the barb. Now it's time to decide which way the water goes through the system. The pump should say which way the water comes out. This is only really important if one of your parts has a recommended way to push the water through. For example, in my case, my CPU water block recommended water to come through one side and exit through the other for best performance. The most effective way I found to put in tubing was to put in one side onto fittings and then make the run to another fitting. After you have done this, use a sharp scissors to cut the tubing at the desired length. Now repeat the golden rule with me. Always cut slightly too much. You can always make it shorter, but you can't undo a cut. Finally, we are at the last step, adding a little bit of water to the mix. First thing you want to do, paper towel everything everywhere, especially around all the fitting. It is time to add the coolant. Now you want to unplug everything from your power supply and motherboard except one thing, the pump. Now you want to find your 24-pin connector and use a paper clip to wire up the 4th and 7th pin with the clip facing up. Golden rule number 2, never run your pump dry. Now you know to never run your pump dry. It's time to not run your pump dry and fill it in with coolant. You can use pure distilled water or a premix like I'm using. Open up one of the reservoir holes and use a funnel to pour in your coolant carefully so there is no spillage. Now turn on your PSU and your pump should turn on in a few seconds. Before all the coolant runs out and your pump goes dry, turn it off and fill the reservoir once again. Rinse and repeat until the reservoir is completely full. Leave your pump running for at least an hour in order to leak test it, while keeping an eye for any leaks. I conducted my tests in an air-conditioned room set at 22 degrees. As for the specs, I had an i7-7700K unoverclocked with all fans spinning at 1000 to 1100 RPM. The testing took 30 minutes off full load on Prime 95. The results are exactly as what you would expect. The $20 air cooler did the worst, at 100 degrees. The $20 air cooler plus another fan performed quite well, closely beaten by the all-in-one cooler, which, no surprise, custom water cooler performed the best. Here are the sound tests, but keep in mind, all fans were at 1000 to 1100 RPM. However, the custom water cooler could have spun at lower speeds and maintained similar results to the other coolers. How does a custom water cooler work scientifically? The laws of physics state that energy cannot be created or destroyed, only transferred from one form to another. Heat is a form of energy. What causes something like a CPU to heat up? A CPU functions by letting electricity pass through microscopic transistors, either letting the signal pass or blocking it. This process transfers electrical energy into heat energy. The harder the task, the more goes through this process and the more heat energy is produced. Something important to know is that every material has a heat capacity. This is how much energy is required to heat up a material by unit of temperature. This is why you often see copper-based water blocks. This is because copper has a relatively low heat capacity, meaning it warms up quickly. You want this so the heat can quickly be transferred to the coolant, which is normally some form of water. The benefit of using water is that it is the single natural liquid with the highest heat capacity. The next significant step in the cooling process is the radiator. The radiator's job is similar to the water block. It is to transfer heat from one state of matter to another. Instead of heat source to water, it is water to air. The water is pumped into the radiator using the pump, which heats up the radiator due to the fact heat wants to be equal and will move from high to low heat. The heat then moves to the cooler fins, which are shaped the way they are to provide maximum surface area between air and radiator. The higher the surface area, the more heat can transfer into the air at a given time. Now it's time for the conclusion. There's more or less no argument surrounding the fact that the custom water cooler is the #1 non-exotic cooler, performance-wise. This should be expected, as it is also the most expensive non-exotic cooler, so should you buy one? If your wallets are large enough, ask yourself 2 questions. Do you have a professional workstation that can actually benefit from lower temps and pushing your parts faster, i.e. multi-hour rendering? Or are you just an enthusiast that loves to fiddle with your computer and likes having the coolest looking computer on the block? If yes, why not?